Okay, here are a few percent problems that we practice in class to work through, showing you how to find the sale price and the original price and the variety of equations that we can use to represent the problem. So we have a situation, realistically, this happens a lot, where the store is having a 30% off sale. So if the regular price of a sweater is $28, what is the sale price? Most of you are okay with solving this problem, but I'm going to work it out two different ways. So I know the sweater is $28 and I need to figure out what 30% of 28 is. Okay, so we can convert our percent to a decimal. All right. Oh, sorry. 30. And we're going to multiply that by 28. All right, most of you are fine with this part. So we can do this with a calculator or mental math, however is best for you. A couple of you are doing 10% and breaking that down 3 times. I'm just going to use my calculator, 0.30 times 28, and I'm going to get $8.40 off the original price. Okay, so then I just can do $28 minus $8.40, and my sale price is $19.60. Most of you are fine with solving problems like this. This goes back to last school year. We did a lot of this last school year. Let me show you another way. I like this way actually. So the other way that we can solve it is we know 30%, and this goes back to our bar diagrams here that we did. We know we have 30%. The other part is 70%, and together that equals the total. So instead of using 30% of 28, let's try using this part. Okay, let's try using the 70%. So if I want to get the sale price without doing subtraction, without subtracting, I can just multiply 0.7 times 28, or 70% of 28, instead of using the discount. So we're using the 30% over here, but let's try using the other part of the total, 70%. All right, 0.7 times 28, and look at that. I got the answer without doing any subtracting. $19.60 is my sale price. Either of these would work. Okay? Now, for the second problem, if the sale price of my blanket is $25, what is the original price? For this one, I'm working backwards, and the best one to use to work backwards is the opposite, the 70%. So this is, we're trying to get back to the original. We need the original. I say we're trying to get back to 100%. Okay? Trying to get back to 100. Now, we already know we took 30% off. So we need to use the other section, the 70%. So I need to say, I'm looking for the original discount price. So I'm going to say, what price times 70% is going to give me that $19.60. Oh, actually, 25. Okay, right, because I'm doing a different situation. $25. So this is my original price. And my original price times 70%, okay, 70%, which is the opposite of 30, 70, is going to give me 25. So this is an algebraic equation. I like to write it as an algebraic equation using a missing number. Change my 70% to a decimal. 0.7 times something, that's my missing number, is equal to 25. I'm getting rid of the zeros just to make it easier. Okay, some number times 70%, 0.7, is equal to 25. So I'm going to divide both sides by 0.7. Okay, 25 divided by 70% or 0.7. Let's see what we get. 25 divided 25 divided by 0.7. Look, okay, that's a weird number, but again, we only need dimes and pennies. So our original price is $35.71. That would be a good estimate. So the original price, I'm going to write it in a different color, $35.71. Now, we can check our work. Okay, we can check by working it backwards. Let's try $35. Now remember, I did round my number, so it might not be exact. Yep, $24.997. Okay, now let's try it this way. $35.71 times 30%, that's my discount, so I'm going to take off $10.71. $35.71 minus $10.31. Oh, hold on. $35.71 times 0.3, $10.71. $10.71. 25. Boom. Okay, so it works. All right, equations. How can we write some equations to represent this? Well, we did a couple here. We could do this strategy where we're subtracting. So we could say that x minus times 30% times x. Okay, so this would represent the first situation. So we're original price, so we could say original price minus 30% of the original. Okay, so that's one way we could write the equation. We put parentheses around it because we need to actually do this first. Sorry, that's supposed to be 0.3, not, and I don't have any white out, but that's okay. Okay, 0.3 x. Okay, the other way is to use this one. This one's easier. This is just 0.7 x. This is just 70% times the original. Okay, so both of these equations work. Okay, so we can use the 0.7 and multiply it by the original, or we can do the two-step equation where we have the original price, we find 30% or 0.3 of the original price, and then subtract. All right, so you have to be able to do these types of problems on the test. It's going to go forwards, it's going to go backwards, and writing an equation is the best way to help yourself solve these problems. Okay, refer back to our notes and the Desmos if you're having some trouble.